easier, but then they can give you hard problems. Yeah. Right? Do you guys want me to give you like a couple minutes to whine about it before we start? I can. Go ahead. I mean, if you want to get it out of your system. We don't have time? It would take too long? Oh, yeah, you're good. I thought you said I don't think we have enough time. We've only got 50 minutes. Alright, go to the back, please. Write down what we're doing. So, L'Hopital's rule is kind of a cheat code for some limits, but then they know you have the cheat code, so they can give you other ones that are more difficult. But L'Hopital's rule. We couldn't do this when we did limits because you need derivatives for it. And this is, if you look on the board, there were two things that we hadn't gotten to yet. And this, I took one out, and we'll get to it later, but it just didn't, timing-wise and like what I want the test to be about, it didn't make sense right now. So we're going to do, this is our last like new topic before the test, and then you're going to have, tomorrow I'm going to give you like a review assignment I want you to do. I'll give you a practice test, and I'll give you time to work on that on Thursday and ask questions. And you're going to have a test on Friday on those topics, including the one we're doing today. Alright? Sound good? Cool. Alright. So, if the limit as x approaches a of f of x over g of x comes out to 0 over 0 or infinity over infinity. So that happened a ton when we were doing these, right? Like that's the first thing you try to do is plug in. Almost always didn't work, and then you'd be like, okay, I'll factor, I'll rationalize, I'll do something, and then try to plug in again, and then hopefully I don't get 0 over 0. So L'Hopital's rule says if that happens, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. Now, so you're kind of taking the derivative, but you're not taking the derivative of f over g, because if I said take the derivative of that, what would you have to use? You'd have to use quotient rule, and this is not quotient rule. This is if I take the limit, and it comes out to one of these two forms, I can take the derivative of the top separately, take the derivative of the bottom, and try to plug it again. And sometimes you'll have to repeat. So, we'll flip it over in a second, but I want to wait till I get started right. So some of the problems we did before, you can just like bypass the factoring stuff that we did before and jump right to 6. But also they're able to give you more difficult problems now because of this. Like if you look at number 2, let's say. So the first thing I'm going to do if I see a limit problem is I'm going to try to plug in the x value. If I plug in the x value, 1 plus 8 is 9, square root of 9 is 3, 3 minus 3 gives me 0, right? Plug in 1 on the bottom, I get 0. So I can't do that. Well, back when we were doing limits, what would you try here? See if anybody remembers that. You do what? This and this, yeah.
Yes.
Yes, thank you. So I multiply by the square root of x plus 8 plus 3. Is that familiar with, like now someone says it? And then the same thing at the bottom. That's just kind of a pain. What you can do now is we can use L'Hopital's rule. If you're on a free response, this is a new topic on the AP test, so they tend to put those on the free response, just like make sure the teachers taught it. You have to go through and say, okay, I plugged in, I got 0 over 0. Write 0 over 0 down, because that is making sure that you meet this stipulation for L'Hopital's. Then you have to write, you can write L'Hopital's if you want, but you have to write LH, so you are telling the grader, I know now that I'm supposed to use L'Hopital's rule, then you can use it. So be careful how you use it too. So it's kind of annoying, like the way I have to write it. If I write it like this, so this is really x plus 8 to the 1/2, right? So if you just go down here and you're like, okay, x plus 8 to the negative 1/2 over 1, you will lose points on a free response. Because what you just said was the limit of this giant thing up here is equal to this. That's not true. It's the limit of this giant thing is equal to the limit of this new thing. So you have to carry that limit down. And we talked about this before with limits, right? You have to carry that limit down until you actually plug in and are able to get rid of it, or else they're going to dock you points. But now, I can plug in 1. So the problem we had before of 0 over 0 goes away. So, this is a good review for it too. With 1 plus 8, that's not the review part. What's the second root of 9? 3. What's 3 to the first power? 3. And then what's the negative do? Flips it over, so it's 1/3. So 1/2 times 1/3 is 1/6 over 1, or just 1/6. The power part, so 1 plus 8 is 9, right?
Yep.
Second root of 9. 3 to the first power. 3. And then the negative flips that upside down. So now it's 1/3. And then 1/2 times the 1/3 is 1/6. Right. Some of the basic I'm sorry, any other questions on that? Some of the basic factoring ones, like look at number 9. And factoring is probably just easier. Depends what you see first in your head, I guess. But if I gave you that problem before, I think most of you would have gone, okay, that's x minus 3 over x minus 3 times x minus 4. Cancel them out, plug in, and you can get your answer done. That's totally fine. You just got to find the limit. But another, like a new option that you have is to use L'Hopital's rule. So if I plug in 3 on top, I get 0. If I plug in 3 on the bottom, 9 minus 21 is negative 12 plus 12, I get 0. So I'm telling the grader, hey, I'm going to use L'Hopital's rule. And then I'm going to go, well, that question that you gave me is the same as if I took the derivative of the top and the bottom. So 1 over 2x minus 7. Now when you plug in, you no longer get 0 over 0, you get an actual answer, and that's the limit. So if I plug 3 into this, down here, what do I end up with? 1 over negative 1, which is negative 1, right? Well, if I did this factor and cancel method, when I plug 3 into here, what do I end up with? 1 over negative, same thing, right? So if I just give you a problem and say find the limit, no one knows or cares how you do it, even on a free response. If this is a free response, they're not going to you didn't use L'Hopital's rule, it's wrong. You just have to do it. So sometimes you're going to have to use L'Hopital's rule, but sometimes you'll have an option. Yeah.
Well, I was just going to ask if they'll ask you to use.
They won't say in this problem use L'Hopital's rule, but they'll give you problems where the only way you can do it is to use L'Hopital's rule. Let's look at another review-ish one. Look at number 13. I don't want 13. I want 16. Limits as x goes to infinity. What does that make you think of? What do we look for? What are we finding? We're finding horizontal asymptotes. So as x goes all the way to this side or all the way to that side, that's where things might level off. We're looking for horizontal asymptotes. What do we look for in the fraction? Yeah, so I'm looking for the higher power, right? Good. So if I plug in infinity here, this is like 2 times infinity, so the highest power is really just 1, because the x is just the first power, you know? If I plug in down here, my power is infinity, so where's the bigger power? The power on top is 1, the power on the bottom is infinity, so the higher power is the bottom, right? And what do we say when the higher power is the bottom? What's the limit? 0. Well, let's pretend we didn't remember that, and we were like, hey, let's use L'Hopital's rule. So plug in infinity. We get 2 times infinity on the top. We get e to the infinity on the bottom. So that's infinity over infinity. That's one of our situations. If the limit comes out to 0 over 0 or infinity over infinity. I'm going to tell the grader, hey, now I'm going to use L'Hopital's rule. So I'm going to take the derivative of the top and the bottom. What's the derivative of 2 to the x? Or, I'm sorry, of 2x. 2. And then the derivative of e to the 2x would be e to the 2x times what? Times 2. And you still, we got choices now. Some of you might see it easier now. Like, where's the higher power now? It's on the bottom. It's a lot easier to see that now, right? Well, let's say you forgot that. Like, I don't. Great. Now what do I do? You can do L'Hopital's rule again. So you can do this as many times as you need to until you get to the answer. So let's say I plug in here. I don't even know. Those cancel. It doesn't really. It's not necessary. But I just want to show you that it would work. What's the derivative? If I did L'Hopital's rule again, what's the derivative of 1? 0. And on the bottom now you have 4 equals 2x. Well, what's 0 divided by 8? So we end up with 0. Even though we're kind of unnecessarily and actually inappropriately using L'Hopital's rule there, it still works. The point there is you can use it twice, and you can use it to do problems with it.
Is it still valid?
No, that's what I was saying, like somewhat inappropriately constructed. Just show that it would work out. Alright, go to number 1. So now they're going to throw a trig in with the L'Hopital's, and this is a problem that you wouldn't be able to do without it. So you might try to factor, cancel, whatever. It's not going to work here. So go ahead and plug in. So if I plug in 0 on top, so I get 0. 3 times 0 is what? 0. Cosine of 0 degrees, so what's the x value at 0 degrees? 1. So then 1 minus 1, 0, right? So I'm going to have to use L'Hopital's rule. So I'm going to take the derivative of the top and the derivative of the bottom. What's the derivative of 5x squared? 10x. What's the derivative of the 1? 0. Yeah.
Isn't 1 minus cosine of x, isn't that like sine of x?
1 minus cosine squared is sine. That's like Pythagorean theorem, like cosine squared plus sine squared is 1.
Yeah, if we got a question like that with the square, can we just add the sine?
You could, yeah. Like that's one thing that might make the problem easier, it might not, but you can try it. So the derivative of 1 is 0. What's the derivative of negative cosine?
Positive.
Positive sine. Leave the little guy alone and then multiply by the derivative of the inside, right? Try to plug it up, see if you get it. So 10 times 0, still 0. And then 3x, so 3 times 0 is 0. And now I want the y value at 0 degrees, which is 0, times 3 is 0. So I'm still stuck. Well, I'm going to just do L'Hopital's again. So the first attempt didn't work. I'm just going to keep going until hopefully it works. If you try it twice and it doesn't work, you're probably on the wrong path. I don't want you on the AB test like you took 15 derivatives. L'Hopital's going to work eventually. Yeah.
Do you have to write the L'Hopital's rule every time?
Yeah. I'm in multiple choice, no, because no one's going to look at your work, you know, but on a previous spots you would. So I'm going to go again. So the derivative of 10x instead. And then remember the trig the constant in front just drops. And then the derivative of sine is cosine. Leave the little guy alone, and then multiply by the derivative of the inside. So now we have cosine of 3x times, so it's like 9 times cosine of 3x. Now I'll plug in 0. So plug 0 in on top. Nothing to plug into, so it stays as it's at. And then 3 times 0 is 0. So what's the cosine of 0? 1. Cosine's the x value, right? So it's 1 times 3 times 3. So now we got an answer to number 2. How many were added me if you already had that? Questions on what I did? Let's do a couple more like together. Try 3. It's got e's in it. It messes people up sometimes. I think the first thing I would do would be distribute that 4. Most of you, I think, it'll be easier to take the derivative that way. But that's up to you. So if you plug in 0 right away, what's e to any power? I'm sorry, I didn't ask that right. What's anything to the 0 power? 1. So 4 minus 4 is 0, minus 4 times 0, so you're still at 0. Cosine of 0 is 1, so 1 minus 4 is still at 0, so okay, we're going to use L'Hopital's. So that the limit as x approaches 0, I'm still writing that limit because I'm still in a limit situation. So the derivative of 4e to the x is, this is the part where you tell me the derivative of 4e to the x. 4e to the x. The derivative of 4 just goes away, and then the derivative of negative 4x is minus 4, right? And then the 1, the derivative is 0. The derivative of negative cosine is positive sine. So if I plug in 0 here, 4e to the 0 is 4 minus 4, so I get 0 again, and then the sine of 0 is the y value of 0, so I get 0 again. So I'm going to use L'Hopital's again. So now the derivative of 4e to the x is still 4e to the x. And the derivative of sine of x is cosine of x. And now if I plug in, I will get 4 over 1. So it's 4. How many had 4? Questions on it? Where'd you get this? Why'd you do this? Anything I can help with there? Okay. I'm all set. I'm done. You guys do some work. So I'm going to give you time to work on it. This will not be like a major emphasis on your test. You spend 2-3 days on most of the other stuff, and this we're spending like 1. But it'll be out there, so be aware of it. Tomorrow we'll do some review. I have an assignment I want you to do. I'm going to have you kind of write a test-ish. Then I'll give you a practice test also.